Now let's look at the circuit connections of a semi-converter, speed control of DC shunt motor. This is the DC shunt motor and this is the control circuit. This is the main kit what you are using for semi-converter. Okay, first let's look at the connections of control circuit. In control circuit we have AC supply as well as DC supply. The AC supply is given from 15 volts transformer. From 230 volts the AC supply is stepped down to 15 volts. Okay, 15 transformer. From 15 and 0 the supply is tapped and given here, and the DC supply 15 0 minus 15 is taken from RPS. Now the connections from G1 K1 G2 K2 are given to corresponding thyristors T1 and T2. Now let's look at the connections of semi-converter circuit. Cathodes of T1 and T2 are connected. Then in the kit itself D1 D2 anodes are shorted, and anode and cathode of T1 and D1 is shorted. Anode and cathode of T2 and D2 is shorted. It's shorted through this wire, and the current transformer CT one terminal is given to this junction T1 D1 junction, and another terminal of CT is given to T2 D2 junction. From here to here, here to here the connection is made. Now from this cathode junction one terminal is going to relay. From relay the connection is going to armature of motor. From armature of motor the supply the connection is going to anode and anode of diode. Now the field connection is going to field of uncontrolled rectifier. Okay, and freewheeling diode is connected across motor terminals. Freewheeling diode is connected across motor terminals. Okay, this is how the connections of single phase semi converter based DC shunt motor speed control experiment is done. Now let's look at the conduction part. Before switching on the supply, you have to make sure that the firing angle is kept at 180 degree, and let's switch on the supply, and let's switch on the DC supply as well. AC supply and DC supply. Let's switch on AC supply and DC supply. Okay, now initially the firing pulse is at maximum. The CRO I am going to connect it across F and common of DC supply. Okay, these 2 points, F and common of DC supply. This will show the firing pulses in the CRO. Okay, and this falling edge is the reference. With reference to this, each small division is 18 degrees. So totally 8 small divisions we have. So 8 small divisions into 8 will give the firing angle. Okay, raising edge is your alpha with reference to this falling edge. So total small divisions covered here is 8, and the time scale is at 5 milliseconds. So each small division is equal to 18 degrees. So the firing angle at this point is 18 into 8. Now measure alpha from CRO and note down the reading speed of motor from the LCD of motor, and measure voltage across motor. Okay, here the freewheeling diode is connected across the motor armature terminals. Therefore the voltage across freewheeling diode will be same as the voltage across armature of DC shunt motor. So when alpha is equal to 18 to 18, the speed of the motor is 300 and the voltage is 33 volts DC. Multimeter should be kept in DC mode because it's a rectifier. Now vary the firing angle, increase the firing decrease the firing angle, and make sure that the speed is less than 1500. Now the speed is 842 and the firing angle is around 7 into 18 and the voltage is 88.7. Now let's decrease the firing angle little more. You have to decrease the firing angle by keeping an eye on the speed of the motor. Now the firing angle is around 6 into 18 and the speed is 1002 and the voltage across the motor is 105.5. Okay, this is what the readings you are supposed to note in case of speed control of DC shunt motor using semi converter circuit.